Pleasant day to everyone. Today we're going to discuss Module 1, Unit 2 of CE 2221, and we'll be focusing on the topic dependent motion of particles. So as we have introduced in the last lecture video, dependent motion of particles is created when one particle or the motion of one particle would depend on another motion of a particle or of several particles. So one situation or example that would create dependent motion would be when two particles are connected by a cord or a string that is around a pulley. So to understand dependent motion, let us solve an example. So given the figure on this side, so if weight A will be pulled downwards at a speed of 0.3 meters per second, what will happen to weight B? Meaning, will it move up or will it move down? And if given now the speed of A, what will be the speed of B? Likewise, determine the relation of their acceleration. So by inspection, we can see that when we pull block A, basically, the weight B will be raised up. Okay? So that is now our answer to the question of what will happen to weight B when A is pulled down. So for our second question, what is the magnitude of the speed or of the motion for weight B? So in solving for the magnitude of the speed for B, we could also confirm later on our answer for the first question, if weight B will really move up when weight B is moving downwards. So for our solution for the speed of weight B, we have to take note that the total length of the cord will be constant, assuming that the cord used is inextensible, meaning the cord will not stretch upon the application of force with the weight being moved down or pulled down. So with that assumption, we can divide the cord or the length of the cord into several segments. So in doing that, we now set our datum. So let's put it in this point. It's at the center of the pulley, bigger pulley. So that's our datum. So from there, we'll now have the first segment, the second segment, you have your third segment, fourth, fifth, and sixth segments. So basically, for this figure, we have 6 segments which will be composed of constants and varying length. So for the constant length that we have, meaning it will not change even if there is movement between the two blocks in our pulley system. So that will be your red highlighted segments. Okay, so with that, we now have the changing length will be the length for weight B, which we will call SB, and the changing length for SA or for weight A, which is called SA. So from here, we'll now be able to get the equation 2SB plus SA plus L constant equals L total. So bakit 2SB? Ito yon, isang SB, second SB. Then we have your SA. So the length constant will simply be the sum of this red highlighted lines. So adding them up will be the total length of the cord. So by differentiation, we now get 2 derivative of SB with respect to time plus D of SE with respect to time plus 0, which is the derivative of a constant, is equal to 0. Or we know that the derivative of a length with respect to time is our speed. So we could simplify this equation as 2VB plus VA equals 0. So since we are given that VA is moving at 0.3 meters per second and it is moving down, so this one now will be a negative value. So we'll assume that our positive direction is the upwards. So substituting now, we'll have VB is equal to negative, so of negative 0.3 divided by 2 meters per second, or that's equal now to 0.15 meters per second. So it is a positive value. Therefore, VB really is moving upwards. So, pag ang nakuha natin is a negative value here, then it means our assumption or our answer in the first question was wrong. But in this case, our answer is correct. So, for the next question, what is now the relationship between the accelerations of weight A and weight B? So, in here, we'll simply use again differentiation, but we'll be differentiating this equation. So we'll now have 2 dVB with respect to time plus dVA with respect to time is equal to 0. Or we'll arrive now at 2 AB since V with respect to time is your acceleration. So from here, we'll now arrive at the relation as the acceleration of weight B will simply be equal to the negative half of the acceleration of weight A. Okay, so next we have example number 2. For the given diagram, at which rate and in which direction must weight A move if weight B is to fall at a rate of 0.3 meters per second? So in this problem, it's almost the same as the first problem, except that this will be a 4 pulley system. So we have here 1, 2, 3, 4 pulleys. Okay? Though our analysis will be almost the same. So again, assuming that our cord is inextensible, it will not stretch. So the length now will be constant again. So for our solution, we will again divide the cord into different segments. So we will have now our datum here. So our first segment will be this one. 2, 3, 4, 5, 6, 7, 8, and 9 segments. So for this problem, we now have the number of segments is equal to 9. So this will be again composed of constant segments plus segment length that is changing when you are pulling A plus segments of cords that will change when we pull B. Okay, so with this, we can now write our equation as the total length is equal to SA plus 4SB, 1, 2, 3, 4, plus our constant lengths. So this will not change even if A and B will move. Okay, so with this, applying again differentiation, we'll now have d of SA with respect to time plus 4 d of SB with respect to time is equal to 0, giving us an equation with for the relationship of their velocities. V of A now is equal to negative 4VB. And since B now will be falling downwards, so meaning point 3 will be a negative value. So our assumption is that the positive direction is upwards. So substituting now negative 0.3 in our equation, VA now is equal to negative minus or negative times the negative of 0.3 meters per second. So VA now will be equal to 1.2 meters per second, which is a positive, meaning VA is moving up when B is moving downwards. So next example. So for this figure, block B starts from rest and moves downwards with a constant acceleration. Knowing that after slider A, block has moved 9 inches, its velocity for that time or for that displacement is 6 feet per second. Determine the accelerations of A and B, the velocity, and the change in position of B after 2 seconds. So for our required, we want to solve for the accelerations of the two blocks. And then B is the speed and the displacement of block B at a time, at instant time, 2 seconds. So for our solution, what we do first is to, again, identify our segments. So for our diagram, we are given now the speed of B initially is 0. We're also given instantaneous speed or velocity 6 feet when we are at a change or delta x of 9 inches. So we'll now assume positive direction is to the left and positive direction downwards. So for our segments, that will now consist of the changing length for A, x sub A. So we'll now set 1 datum at this point, which will define the segments for B. So we'll have here y sub B. Then we have here the distance between the two pulleys A. So for our equation, for the accelerations of A and B, so from the diagram, we can now get that the total length is equal now to 2YB plus YB minus A plus XA. So we have 2YB plus, or this YB plus YB. So this is the YB minus A and XA. Okay. So at point C and at point D, these distances will vary now. Okay. So with this, simplifying our equation, length is constant, A is constant, so we'll arrive at the equation 3YB plus XA is equal to a constant value, and deriving it will now arrive at 3VB plus VA equal to 0, and further deriving it will have 3AB plus AA. So from our derived equation for the accelerations of B and A, we can now take that the acceleration of block A is equal to -3 of the acceleration of block B. So in this case, we now have AB will be moving downwards, and we have assumed that downwards is positive. And we have A is negative, and from our assumption, the positive direction is to the left, so therefore negative of left will be moving to the right. Okay, so for slider A, we now have the equation v squared is equal to vo squared plus 2a delta x. So for A, since we are given delta x and an instantaneous or final speed for this change, then we can directly substitute it in this equation. Okay? So since A is moving to the right, which is our assumed negative direction, then applying or substituting our value, will have -6 feet per second is equal to 0 squared plus 2a times 0.75 feet, which is the converted value of your 9 inches. So from here, we'll be able to get that the acceleration of block A is equal to -24 feet per second squared. Negative meaning it's opposite your assumed direction, so it's moving to the right. And then for slider B, we have taken now this relationship between A and B. So acceleration of A is equal to -3ab, and we have solved already for the value of A here, that's -24, so it's equal to -3ab. So we can now solve for the acceleration of block B as +8 feet per second. So positive yung na-solve. So nandun siya sa positive assumed direction natin, which is downwards. So therefore, block B is moving downwards. Okay? So next question, what will now be the speed of block B and its change in position or its displacement at the instant time of 2 seconds. So for this, we'll be applying the equation V is equal to V sub O plus AT. Okay, so we have already your V sub O, which is 0. We have solved for the acceleration of B, and we are given the time t. So it's just simple substitution. So we'll have now V of B is equal to 0 plus negative or positive 8 times 2, and it will give us 16 feet per second. So it's positive, so again, it will be along our assumed positive direction, which is downwards. And then for our change in displacement or position, that will now be y. We'll be using y is equal to y sub o plus v sub o times t plus 1/2 at squared. So if I transpose y sub o in the left side of the equation, that's y sub b equal to y sub o of b. Okay, this will now become our delta y sub b. So substitute our other given. V sub o is 0 times time 0, 1/2. Acceleration is 8. At the instant 2 is our time, so squared. Therefore, after 2 seconds, B has already traveled a distance or displacement of 16 feet downwards. So positive. So again, so in this case, if we are going to draw it in our diagram, block B is already at 16 feet. This is at t equal to 2 seconds. So that's it for dependent motion of particles. So for references, you can check on this website.